So the first session is titled Innovative Tools, Transformation Through Cyber Infrastructure. And I will be the moderator of this particular one. So transformation through cyber infrastructure. What is cyber infrastructure, right? We've used this word a whole bunch of times today. I thought I'd start with a quick definition. Cyber infrastructure is the integrated system of digital resources, services, and tools that enable advanced research, collaboration, and data management. It encompasses a wide range of technologies and components, including high-performance computing, data storage facilities, and advanced networking capabilities. It also includes the software that we use and the human expertise. So we have to include the collaboration around cyber infrastructure within the term itself. The ability to collaborate around system models and data visualizations are hallmark features of cyber infrastructure, and it's very much at the core of what the Chesapeake Global Collaboratory wishes to do. So, this summit is part of this commitment of UMCES to build a hub for cyber infrastructure and enable interdisciplinary science using cyber infrastructure. And so to do this, we've invited 3 panelists to discuss with us how they've been involved in cyber infrastructure and in research programs that utilize it. Our first panelist is Victoria Coles. Victoria is the Associate Director for Research and a professor at the UMCES Horn Point Laboratory in Cambridge. Welcome, Victoria. Our second panelist is Marco Masciola. He is a Senior Partner Solutions Architect and Technical Lead for the Global Sustainability Partner segment at Amazon Web Services. Marco clearly stands out as our industry representative here. Marco? Thank you. And our third panelist is Vandana Janaja. She is professor and chair of the Information Systems Department at the University of Maryland, Baltimore County. Vandana will soon be transitioning to the role of Associate Dean for Research in the College of Engineering and IT at the University of Maryland, Baltimore County. Vandana, please. So you all have a microphone, and is it turned on? Would be the next step. The first question is really just to get a chance to know you. If you could introduce yourself and tell us a little bit about how you've been involved in cyber infrastructure, what types of research projects, and how you got involved, that would be great. Maybe we could just go from left to right here, and Victoria could answer the first question first.
Sure. So hi, I'm Victoria Coles, and my background is as a 3-dimensional physical oceanographer modeler, and so that's kind of how I got into this business. Can you hear? That's that better? Okay. Was through working with very large data sets and creating them essentially. But what, from the perspective of this collaboratory, what kind of brought me into the assessment of, or the arena of big data beyond my own was thinking about climate impacts over the Chesapeake Bay region and starting to work with the very large data sets that the Intergovernmental Panel on Climate Change generate through their Coupled Model Intercomparison program. So that was, those tools, or those data sets, are extremely hard to work with if you don't have the kind of infrastructure, both physically through the ability to transfer data at high rates, and also the tools to work with data sets that you can't just necessarily carry around in your spreadsheet or easily hold in memory on your desktop computer. So,
thank you. Perfect. Marco?
Can you hear? Yeah, Marco Masciola. So yeah, I'm with Amazon Web Services now, and as a partner solutions architect, what I do is I help climate tech startups scale and build on AWS so they could make their offerings available to virtually anyone. Prior to Amazon, I worked in wind energy for 10 years, so I'm very passionate about grid decarbonization. And I worked in various elements of wind energy design, working with the U.S. National Laboratory, more on the research and development of open source software to model floating wind turbines. And I worked with a OEM, a manufacturing, one of the big three manufacturers on actually designing these products. So my connection with cyber infrastructure is related to the data pipelines, the data warehouses that we need for running simulations and enabling concurrent engineering processes so that many engineers could contribute to the design of wind turbines and further optimize them for the next generation of design.
Thank you.
Can
Vandana?
you hear me?
Yep.
Okay, great. All right. So my brush with cyber infrastructure, it starts way back when, looking at spatiotemporal data science from the data science side of it and from the machine learning side of it. In my other hat, I also direct an NSF institute called Harnessing the Data Revolution for Models and Data in the Polar Regions, called IHARP. And a lot of discussion there is around the complexity of the data, complexity of bringing multiple disciplines together, complexity of the system. So for me, cyber infrastructure is really not just hardware, but it's about people, software, data, and interdisciplinarity. And I think earlier somebody had talked about the feedback loop going back to policy. I don't want to miss that as well, because that's an important part of building the infrastructure ready for doing science. So that's a little bit about my interest in cyber infrastructure. I would be remiss if I didn't mention training as a big part of it. So cyber infrastructure is not just for the elite. That's my pet peeve, if you will, or my soapbox. I won't get on it. But cyber infrastructure is for everyone. So training all types of backgrounds, students from all types of backgrounds, training different disciplines so that we can advance the science is where I see it.
Great, thank you. So now that we know a little bit more about each of you, I thought maybe we could talk about experiences you've had that really highlight how cyber infrastructure has advanced research and development in your field. Maybe Marco, would you willing to take the first stab at that question?
Sure. You know, I saw cyber infrastructure take hold in three different R&D activities that I've been involved with. One of them is wind energy. That'll be the first one. Second one is robotics. Very early on, 10 years ago, before I got into wind, I was a researcher in robotics, and that was my foray into you know, using open source tools and collaborating with folks that I never met before virtually, and using this digital tunnel known as GitHub to you know, exchange source code with. Then the third one is on geospatial modeling, and I think this is something that's taking hold right now before our very eyes, that we're starting to see how these geospatial data sets are being leveraged for the betterment of society. That, you know, optimizing route planning just by monitoring traffic patterns. What we're starting to see is emissions tracking using satellite imagery. And I think the next leap, which we're seeing it happen today, is layering machine learning on top of geospatial data sets to then augment what we don't see underneath the various images. So, you know, those are three areas where I do think cyber infrastructure could play a role. Just pivoting back on wind energy, because it is my passion. I think with wind energy in particular, there's, you know, we see climate change happening, and wind turbines are designed for 20, 25 years of operational lifetime, but they're designed for the environment we see today. So with cyber infrastructure, it's an opportunity to work with the science community to understand, are we building and designing wind turbines for the right environment that we are going to see in the future?
Great, thank you. Who wants to go next?
So we heard an awesome talk this morning in which our speaker pointed out that most modelers use the model that their advisor taught them to use. And so I kind of wanted to present a little bit of a vision for how, the way we work this is that we get trained in our domain, and then if you're a computational person, you sort of scrabble down the road after the computer scientists trying to pick up these tools on the fly. And so imagine this concept for the cyber collaboratory. Oh, is that a little better? Where you can actually collaborate actively with people who are pros in the cyber infrastructure domain. So then we don't have to be tethered to these models that we know and we can use because we've been trained in them. We're going to be able to more rapidly shift our focus to different types of models, but even more importantly, we can connect them more effectively, because solving the kinds of challenges that we have with climate require going a little bit beyond the physics and a little bit beyond the biogeochemistry and maybe even past the zooplankton to actually talk about things that people care about, like fish, right? But it's very challenging to make those connections, and we really need to leverage some of the modeling tools and technologies that the cyber infrastructure people are pros at. And so this is kind of the vision that I have as part of the collaborator. I'm getting all excited here and passionate about this, sorry.
Thank you. Vandana, yeah.
Specific examples that I can think of from the iHeart world. It's very hard to connect what's happening on the polar science or the polar regions back to your own backyards. That's what we're trying to do, to connect the dots and reduce the uncertainty in how we model sea level rise. It seems like a very big goal, and it is, because there's so many different disciplines studying the polar regions and the disconnection from the polar region all the way to your backyard, and how the flooding happens in your backyard and how's that connected to the changing climate cycles and so on. And that we've seen in iHarp as well. We started this interesting project where we heard from the polar scientists that there is a need to use computer vision to map out the endglacial layers, which is the layers of ice under the ice sheet. It's a very interesting computer vision problem. We started tackling it and really understood the impact of it. Why do we want to know it? That actually helps us understand the age of the ice. And that helps us understand where is the ice melting, where is the ice sheet going to break off, where is it going to go into the sea and raise the sea level. Very, very interesting dynamic in the connections. Another interesting project where we are looking at melts happening in Greenland. All of this is about melt and how the melt impacts the sea level rise, how that impacts our eastern shore or other shores where we know by 2035, there's going to be impact. I think one of the policymakers mentioned Crisfield. That's facing impact as we speak. Now, where does cyber infrastructure come in all of this? All of the data that we're talking about is massive, heterogeneous, coming from different disciplines, different domains. So we have to bring in these disciplinary foci, bring in the cyber infrastructure professionals and the scientists together. There's lots of room to cover all of that, understand the science. There could be disagreements. How do we annotate the data? How do we do all of that stuff? That's why I said it's not just machinery, it's people, it's data, it's software, and training, because this one student who was working on the MELT project for Greenland tried doing some stuff on her own, tried getting some help from a advanced computing facility. She was pointed to links and this and that, but until we got her connected to some of our infrastructure professionals, some of them are here, it didn't change. It didn't change for them. And when she started working with the infrastructure professionals, that's when she started advancing the science. So it's a full cycle, I think, including training as well.
Thank you, Vandana. There's really been an increase in the emphasis of open science and open data science. And I think there's some challenges related to that. I wonder how you've approached those challenges in your work and how they're related to the growth in CI at the same time. And I'll just remind you, hold the microphone close to your mouth the whole time, because it has a very narrow cone.
All right, thank you. I'll try to do that. Maybe you'll indicate me if I don't do that. So in terms of open science, there's open science and open source. I always see them together. There's different challenges for both sides. But in terms of open science, the biggest aspect I feel is data, if you're dealing with data that's findable, accessible, interoperable, reproducible, but then also the care aspects of it, which is, who has the authority on the data? where is the responsibility of the data? Or what are the ethics of using the data? Are we just using the data, producing the science, and forgetting about the community? Is there a feedback loop? And which is why I brought in the policy loop as well as the community loop. So those are some of the important aspects of open science. The biggest challenge, in my opinion, so far, what I've seen is getting access to the data that is somewhat, I don't want, maybe territorial is not the right word, but scientists, researchers who are doing the science, they're protective of the data, and rightly so. Communities are protective of the data. But if there can be good scaffolding around the data, if there can be co-creation, I think one of the speakers talked about the co-creation and transdisciplinarity, that's when we can actually advance open science. The biggest aspect in AI, I think anybody who has done AI knows the bane of AI's existence is annotated data. If you don't have good annotated data, all of this doesn't go anywhere. So how do you get annotated data in an open science environment is only when you work across disciplines. Only when there is a closed loop, a connection that here's the data we're going to take, we're going to protect it, we're going to have authorship rights and all of that good stuff, and we're going to bring it back to the community. All of this is not easy. It's very hard. Some of the people aspects are actually harder than the science aspects. So.
Marco, would you like to comment on that one?
Yeah, I think you hit the nail on the head. Similar theme. I think there's two additional elements that I could lay on top of that is data reproducibility and enabling collaboration so that you're working across different science domains to solve the really interesting problems. And this is a personal viewpoint, but my perspective is to solve climate challenges today, it's a systems engineering challenge. It's a social science challenge as well. And there's trade-offs. In solving one challenge, you have a potential negative side effect on another discipline. So I see the perspective that cyber infrastructure enables this collaboration so you truly understand and appreciate what the trade-offs are and where that equilibrium exists to push the frontier further in a meaningful and impactful way that you're just not trading benefits. So that's one perspective. Pivoting back to reproducibility, I think this is something that some of us have experienced in research, that we read a paper, we want to reproduce the results, it's hard to do. I think cyber infrastructure is one way for enabling that collaboration, that you see how your peers in this domain achieve the results that they did, and then you could augment your own understanding and your own models to what they've already achieved. And that really pushes the frontier further, rather than just merely going through the motion of doing what they've already done, but adding and contributing to something that already exists.
Great, thanks. Victoria?
I think we've heard some great comments already, but one thing that I wanted to circle back to is how open data and open science enable a democratization process amongst the stakeholders. When people can see and work with the data themselves, they begin to understand a little bit more what you're talking about. And so some of that process of bringing data sets together and providing them is also about visualizing them and about enabling others to visualize them themselves. And so when we talk about meeting with stakeholders and engaging them in the process of knowledge co-production, that also includes their ability to contribute data, to work with the data, and to have that interaction. And we can't do that unless we make this process a little bit easier and we enable it with some of these cyber infrastructure tools that we've been working on. And I just wanted to call out one thing that Erica said earlier, but I think really piqued our whole table's interest was, recognizing that there are ethical concerns with the production and use of data, that we should be having active discussions with our students and our stakeholders, about before we just dive into some of these issues.
Great. So I think I have one more question, but we can open the Mentimeter maybe now. And then you guys can pose some questions using Menti to the panelists as well. But while you're doing that, maybe we could talk about training for a minute. Victoria, would you like to start? I mean, how do we train the next generation of CI experts?
So I was inspired by our river keeper. I don't know if he's still here. And I wanted to, oh, there you are. I wanted to tell a quick personal story. So I don't think I had appreciated fully how much my early upbringing contributed to my ability to dive into data and programming. As it happens, I grew up in San Diego. Hi, Californians. And I was bused to a magnet school where we learned to build compilers in the 10th grade. We had a PDP 1160, any of you like computer geeks. It was amazing. But at that time, this was actually early in the kind of computing revolution. I'm really old. And we were both male and female in equal measures in those classes. I didn't know programming was for men, okay? And so that gave me a real step up when I got into college and graduate school. I didn't view that as something that was exclusive to women. And so this is one of the challenges that, you know, we really have. Our cyber infrastructure communities aren't as welcoming to women, minorities, people of color as they should be. And so I just came back from this NSF-sponsored workshop, and we talked about the hidden curriculum. We talked about the missing semester, skills that students don't necessarily come into environmental science with that really all of our students should be learning so that they have the ability to exploit these kinds of new and emerging technologies. And not only that, that's what we need for workforce development. That is what our students are, that's what's going to give our students an edge when they go out into the world with a degree from UMSIS, is having these core competencies that make them very attractive in the environmental science field and in industry as well. So, I mean, I guess that's really an impassioned, you know, call to teach these things rather than an idea of how to do it. But
Thank you. Marco?
Yeah, this question I was a little torn on because I wanted to hear the perspective from the folks that are teaching and instructing in university, because I want to understand what the gaps are, because you know, one of our mandates is to make sure that the resources to help and train folks, they're out there. And you know, my opinion again, you know, as far as how to use and leverage cyber infrastructure and deploy a model on the cloud, you know, tends to be tailored for someone with a computer science background. And I think one avenue to democratize access to how to use these resources is to have specific workshops that are focused for the discipline that the scientists want to engage in. For example, you know, deploying a climate model, or how to do natural resources and water management. How do you deploy these things in a fashion where you're running machine learning under the hood? These are workshops that, you know, can be constructed for the discipline that you're instructing for. You know, I think that's a side effect of you know, some of my exposure not having a pure computer science background, but always dabbling in it, and now working in cloud, that it is a steep learning curve, and I do recognize that, and I think many of us do. But you know, it's just a matter of creating a workshop and a curricula that is not heavily focused on the computer science aspects, but communicates it to the inner science and all of us.
Thanks. Vandana?
I'll just say something quick. The first thing we have to do in training cyber infrastructure professionals is throw out every single assumption that we know about cyber infrastructure. One of them being they should come in with this knowledge of Unix or that knowledge of Linux and these type of commands, and they should be able to read complex documentation. Every assumption should be thrown out. The reason being that our concept of no prerequisite courses may not match what students come in with. So one example I'll give you is we did this translation of a course from UC Berkeley. They have a very well-known Data 8 course, which is a no prerequisite 4-credit course. We wanted to translate it to UMBC. We started the foundations course. Again, we had to make it 3 credit. We also had the same assumptions, it's no prerequisite. We started getting all types of students, arts, theater, economics, all types of majors. But within a few semesters, we realized that no prerequisite is really not no prerequisite. That goes back to the hidden curriculum. There's an understanding that these students have done computer science in high school. There's an understanding that they've done statistics or they've done some type of probability. Many of them don't come with that. Some of the students may have had exposure. So we went back to the drawing board and figured out that there are some key concepts that are missing even in this no prerequisite course. So now we are in the process of revising that. UC Berkeley is in the process of revising that. So I think that's my punchline, if you will, throughout all assumptions that we have about it.
Great, thank you. So there's some questions here. I don't know how to approach this exactly. If one of you sees a question here you'd like to respond to, you certainly can go for it. I see that there's one specific to Marco here that says that we should learn from, Marco has said that we should learn from other cyber infrastructure work. What facilitates that learning from others?
Yeah, this might be a good opportunity to call out IEA Task 43. And the International Energy Agency, they have various tasks around renewable energy adoption globally. And with IEA Task 43, it focuses on wind energy digitalization. And that's a big word for just meaning they're trying to come up with an open data standard on how information is transmitted between different stakeholders that work collectively in a wind energy industry. And something as simple as wind resource assessment, how much energy is in a wind. If you talk to all the stakeholders that are involved in one project, they all come up with a different number. So as part of IEA Task 43, what they're trying to do is leverage the work that university researchers have created that they believe is validated and the latest research and the best practices on how to do wind resource assessment, and attach it with an open data standard model so that now you have consistency throughout the wind energy value chain, going from the design of the asset to delivery of the asset. And this is an open standard that I believe that it could be leveraged in other industries such as solar, or if we talk about water resource management, it's fundamentally a data warehouse that helps break down silos between different entities that are part of, that are attached with the lifetime of the asset. So, that's one example that, it's an open data standard that could be reused in other disciplines, but it's also just an example of a roadmap of how to go about solving these highly both technical and socially challenged scientific problems.
Great. Did either of you pick a question here you'd like to respond to?
I think there are a couple of interesting questions here around taxes for Maryland, property taxes, and there was a question around fining polluters, I think, is that right? Fining polluters?
Polluters.
Polluters, right?
Yeah.
These are very interesting questions because it shows the importance of not just looking at science purely, but connecting with policymakers as well. We can do all the science we want, but until it connects to the policymakers, I don't think we can do those things. So those are hard questions, and that's why I was really impressed with all the policymakers who spoke in the morning. They all were really attuned to the data. They were really attuned to what's happening. And I think those are the types of connections we need to keep making. So I don't have an answer, but I really felt that was an interesting question.
So this question, I don't know if you can you see them all up there? Oh, you can, okay. So that also touches potentially on environmental justice as well, right? So when we look at these problems, this is what we're talking about. It isn't really just understanding glacial melt in Greenland. It's also understanding the ocean circulation and the movement of the north wall of the Gulf Stream. That's me. It comes into the estuary, and we have to have people that understand the variations in the tides as sea level rises. And then it starts to touch onto the economics of losses. Insurance companies are very interested in this. And sea level rise impacts communities very differently, and their responses are very different depending on the resources they can bring to bear. So I think this is really where this whole collaboratory comes together, is recognizing that, you know, maybe I can do the ocean and the tides part, but we really need to be working in a much broader coalition to address some of these questions and include those kinds of assessments.
Great. Is there another, how do I get to the next page of, it doesn't, there should be another page of questions, but, oh, yeah, we're about to get it. Yeah, we're sort of wrapping up on time anyway, but I thought maybe we could see what the next page was. I'm sorry about that. Well, thank you so much for this panel discussion. I learned a lot. I hope everyone here appreciates the deep insights that we got from the three of you. So thank you very much.